Before anything else, Paul, let's have a quick review regarding the past lessons that we had. The first statistical test that we discussed is one sample z-test. We use one sample z-test if we want to determine if the given sample is a representation of a given population. And also, we use one sample z-test if the number of samples in the given problem is greater than or equal to 30. The second statistical test that we discussed is one sample t-test. We use one sample t-test if we want to check if the given sample is different from the given population. And we also use one sample t-test if the number of samples in the given problem is less than 30. Now proceed with the third statistical test that we will discuss, and that is t-test for proportion. And this is lesson 10 for the entire semester and the first lesson for subquarterly. We use t-test for proportion if we want to check if there is a difference between two data sets where data are in proportion. So this is functioning just like the same with one sample z-test. It's just that the given values for this statistical test is in proportion and not in terms of mean and standard deviation. And since this z-test for proportion is the same with one sample z-test, the types of the variables that we will encounter is in the scale of interval or ratio, and also the number of samples should be greater than or equal to 30. The formula for z-test for proportion is p hat minus p all over the square root of the product of p and q all over n, wherein P hat stands for sample proportion, and P is equivalent to population proportion, and then Q is equivalent to 1 minus the population proportion, and N is equal to the total number of samples. I would just like to inform you that there is another formula for z-test for proportion, but that formula is for a different set of given values. Now, wherein this formula is for problems wherein the given values is a percentage and parang one set of proportion. Pero yung other formula is for values wherein or for problems wherein the given values are two sets of proportion. So, we'll just stick with percent tapos one set of proportion so that you will not be confused. Let's begin with problem number 1. The principal of senior high school needs a secretary and need the approval of more than 70% of the faculty members. Out of 65 members of faculty, there are 58 approved the need of the principal. Is it significant to appoint a secretary? Use zero point 0.05 level of significance. First step is to identify the null and alternative hypotheses. We will use the first statement as the basis for our null and alternative hypothesis since this is a factual statement in this problem. Our null hypothesis is population proportion is equivalent to 0.70 since if we will go back to our first sentence, the numerical value given for the factual statement is 70%. And for the alternative hypothesis, since the statement in the first sentence is approval of more than 70%, our alternative hypothesis will be the population proportion is greater than 0.70. Or you can also use 70% if you want to. Second step, we identify the alpha level and the tail test. The level of significance in this problem is directly stated as 0.05. So automatically, our alpha is equivalent to 0.05. I don't know if I already mentioned to you this one, but the parang purpose of level of significance is that you're giving your predictions or this process a 0.05 level of or parang error na you will be wrong pero a chance of being wrong is just 0.05 level. Parang ganon. To identify if this is under one-tailed test or two-tailed test, we have to go back to our alternative hypothesis and check what is the mathematical symbol did they use. So going back, we use a greater than symbol. So since we use an inequality symbol, then therefore, our tailed test is 1. Step 3, identify the statistical test that you're going to use for this given word problem. And since the values given in this problem is in proportion, then automatically this problem is under C-test for proportion. If you will ask me, ma'am, where's the given proportion for this problem po? So kindly check the second statement in this problem. Diba we have, out of 65 members of faculty, there are 58 approve the need of the principal. So from that statement, we can say or we can conclude na it's a statement for proportionality. That's why this problem is under C-test for proportion. Step 4 is the computation. For solving, we have to identify the given values first. So we will start with the sample proportion. For us to get the sample proportion, we have to look for a statement wherein they discuss or state a parang statement of proportionality. So for this problem, di ba, we already identified that the second statement is parang reflecting a proportionality statement. So this will be the statement that we will use, or parang this statement will be our basis in getting the sample proportion. So from the statement, we have out of 65 members, there are 58. So meaning to say po, our X is 58 and the number of total samples is 65. So the proportion, sample proportion is equivalent to 58 all over 65. And we have to rewrite this fraction form into a decimal form so that we can compute easily. So just make sure that all the numbers in this problem will be rounded off to 2 decimal places. Okay po, again, all the numbers that we will use for this lesson will be rounded off to 2 decimal places. So dividing 58 by 65, our answer will be 0.89. For our population proportion naman, we already stated in step 1. So, our population proportion is 0.70. Then for Q, we have the formula 1 minus P. So, all we have to do is substitute the given value for the P in this mathematical statement. Then you simplify to get the value of the Q. Since P is 0.70, we substitute it in the given mathematical statement. We will have 1 minus 0.70. Simplifying, we will have 0.30 as the value for the Q. Now that the values are complete, we can now substitute in the given formula for z-test of proportion. Substituting, we will have 0.89 minus 0.70 all over the square root of 0.70 multiplied by 0.30 all over 65. The calculator on the left side shows you how are you going to input the values if your calculator is a 4-liner calculator.
Minus 0.70 or 0.7 and then bring down the cursor. Tapos you press yung square root symbol first and then the fraction sign and then you can use 0.7. You can use the multiplication symbol or you can also use the open and close parentheses. Pero I'll use the multiplication symbol, then 0.3 or 0.30, and then all over 65. Then you press equal sign, then that will be the answer. So for two-liner calculators, you have to press open parentheses first, then you type 0.89 minus 0.7 or 0.70, then you close. And then you have to press the fraction symbol and then open parenthesis, and then square root, and then open parenthesis, and another one kasi yung this parenthesis will be intended for the numerator, and then this parenthesis will be intended for the whole fraction. So 0.7 multiplied by 0.3, then you have to close. So this first pair of parentheses is for the numerator. And then you press fraction again for the denominator, and then you type 65, and then you have to input two parentheses kasi this one is for the whole fraction na 0.7 times 0.3 all over 65, and this one is for the whole denominator itself. Then you have to press equal sign to show the answer.
After calculating, our z computed is 3.34. Step 5 is the decision rule. We are still under z-test, so the decision rule is the same with one sample z-test, and that is reject null hypothesis if the absolute value of z computed is greater than or equal to the absolute value of the z tabular. Just like what I've said, since this is still under z-test, we will also use the table that we used for one sample z-test. And for us to get the values for the C-tabular, we have to go back to our step 2 to identify the alpha level or level of significance and the number of tailed tests. Going back to our step 2, we have the level of significance as 0.05 and the number of tailed tests is 1. Since our level of significance is 0.05, we have to draw an imaginary vertical line that will pass through 0.05. And since this is under one-tailed test, we have to draw an imaginary horizontal line that will pass through one-tailed test. And the intersection of the horizontal and the vertical line is the value for our z-tabular. Substituting the values for z computed and z tabular, we will have the decision rule as reject null hypotheses if the absolute value of 3.34 is greater than or equal to the absolute value of 1.645. Step 6, identify if we have to reject the null hypothesis or we fail to reject the null hypothesis. We have to go back to step 5 to check if the given mathematical statement is satisfied or not, so that we can know if we have to reject or we failed to reject the null hypothesis. So going back, we have the absolute value of 3.34 is greater than or equal to 1.6 or the absolute value of 1.645. So obviously it's true. That's why our answer is reject null hypothesis. Next step and last step for this given problem is the conclusion. In forming the conclusion, it is already stated in step 6 that we will reject the null hypothesis. So our basis for the conclusion is the alternative hypothesis. And if you will go back, the alternative hypothesis is that the population proportion is more than 70%. That means that the principal of senior high school needs a secretary and the approval of more than 70% of the faculty members is attained. Or you can just state it in a way na you will just base it on a given question na, di ba? The question is it significant to appoint a secretary? So you can state it as, it is statistically significant to appoint a secretary. Kasi nga po, we reject the null. So, we will appoint a secretary.